Good day to you. I am Michiel and I work as a researcher at Delft University of Technology and also as a consultant at Significant. My main topic of interest is freight transport modeling. Currently, I am mainly focusing on the development of microsimulators for urban freight and logistics. In a recent study, we have analyzed a very important challenge in urban planning, the transition to zero-emission city logistics. What will I present to you in this short course? Let me please share my slides with you. I will give you a sort of crash course on how we used multi-agent simulation to study the impacts of a zero-emission zone in Rotterdam. Rotterdam is one of the first cities in the world that has announced to introduce a full zero-emission zone by 2025. So this will change dramatically the operations of city logistics. How, this is not known yet, and it's important to know this on beforehand. For the city, they want to know this because they need to facilitate this transition to zero emission. And also they need to mitigate the impacts towards a sustainable development. Well, for each logistic segment, whether it's retail, whether it's food and restaurant services, manufacturing, building constructions, they will each adapt in a different way to the introduction of the zero emissions. We study this using multi-agent simulation. Well, first of all, to introduce you to the case study, Rotterdam is one of the major cities in the Netherlands. It's in the middle of the province of South Holland. This is a highly urbanized area in the western part of the Netherlands with a total population of 3.3 million inhabitants. Here you see in the map in green the location of the zero emission zone within the city center of Rotterdam. Now, what will happen if the zero emission zone is introduced? We based our scenario analysis on an expert report called the Roadmap to Zero Emission City Logistics, which was published by the municipality of Rotterdam and developed together with TNO. Well, there are two typical responses that are expected. First of all, companies will change their operations by buying a zero emission vehicle. This can be a hybrid truck or a full electric truck. But also for companies that don't have the resources for this, or they choose for a different option because it's more cost efficient, they will consider consolidation using an urban consolidation center. And from this urban consolidation, there is a zero emission last mile delivery within a city center with either a cargo bike or with light electric trucks. This can be a variety of vehicle types. We did in our simulations, we assumed or we set up these scenarios for each logistics segment, how they will adopt to this introduction and how their responses will be. So we based on the roadmap for zero emission city logistics, for each logistics segment, we could derive expected vehicle shares in zero emissions. So for instance, for parcel and express deliveries, 50% will be delivered by electric vans and 50% by light electric vehicles, such as cargo bikes. Also, we made assumptions about the different consolidation potentials, which also varied across each logistics segment. And as you can imagine, for waste collection, we assumed a percentage of 0, but for other segments, these are higher. Well, how do we quantify the impacts? So we used a multi-agent simulator for this, called MassUT. This simulator simulates logistic decision-making of all the companies at the individual level. So based on the type of flow, you can also simulate the changes as a response to the different policy measures. The simulator has a layered structure. So first there are more long-term logistic decision makings like producer supplier choice, shipment size choice, and vehicle type. This is the shipment synthesis module. And then there's a module called scheduling module in which the daily decision making is simulated. This includes the formation of round tours and also the time of delivery for shipments. And finally, a network module is used to determine the paths of all the freight vehicles in the study area and to derive the necessary indicators. Well, the simulator is calibrated and validated, so it also can provide valid estimates of the impacts. And in this case, we looked into zero emission zones and we based this analysis on transition scenarios that I've just introduced. This is a visualization of how the shipment patterns change. I explained part of the shipments will be handled through urban consolidation centers. This is kind of an abstract figure, but here you see what happens. So part of the shipments, they will, instead of directly to the customer, they will go through the urban consolidation centers, and from this, the first and the last mile is done by zero emission zones. And the share of to what extent these urban consolidation centers are used, it varies across the logistics segment. Now, if we calculate all the emissions, if we want to know the emissions or the impact of the zero emission zone on the total emissions in the study area, we calculated these from all the vehicle movements that we are simulating in this scenario. In total, we can aggregate up these results and then visualize them in the map, which you see here on the right-hand side, or calculate the total statistics. When we look at the emissions, we can look at the emissions only in the zero emission zone, at the level of the city of Rotterdam, or at the level of the total study area, the province of Zuid-Holland. And what we see at network level, the reduction of CO2 emissions in the city of Rotterdam measures up about 8 to 9%. This is quite considerable. Please bear in mind that a lot of the freight traffic that is handled in the city of Rotterdam, it is port related and it's long haul transport back to the hinterland, and this is totally unaffected by the zero emission zone. So still, this is quite a considerable share if only the city center is impacted by this measure. And what you can also see a little bit already in this map, some of the areas in the network, they are light reddish, which means that there's an increase in freight traffic or an increase in the emissions. This is the result also of rerouting behavior or rerouting decisions, and that parts of the shipments, they need to be redirected to the hubs, or other deliveries, they have to take a detour around the city center because they cannot pass through it. So there are also secondary impacts that need to be considered. Well, this detailed simulator also gives you the opportunity to zoom in. And then if we zoom in to one of the logistics segments, in this case partial delivery, you see that the operations of partial delivery, it can have quite dramatic impacts, and that even on the orbital ring roads there can be quite strong increases for this particular segment, which are the results of how partial delivery is organized. So they don't have a very dense network of depots from which the deliveries are being done. So there's a lot of vehicles that have to drive around the city to go to the urban consolidation center, which is either at the other side for the last mile delivery in that area of the zero emission zone. So this rerouting behavior is something to definitely to consider when planning these zero emission zones. Conclusions from the study. This was just an introduction, of course. What we measured in this particular scenario that we have chosen, well, inside the city, zero emission zone, there are dramatic reductions in emissions, of course. At the city scale, it was around 10%, and for the characteristics of Rotterdam, with the large port, etc., this is still a significant impact. So we see that the impacts are not trivial, so you can also see secondary impacts because of the rerouting behavior of vehicle movements. And also, It's nice that we are greening city logistics. It's a good step towards climate ambitions, but of course, much more measures are needed to reach the climate goals and to further decarbonize also the long-haul freight transportation. Well, this is also a short introduction or illustration of how multi-agent simulation models can be used to allow a better representation of stakeholders in your analysis, and also implement particular scenarios of their responses to how they are affected by the policies of in city logistics. And currently, we realize that this is very much based on these scenarios we are assuming, and currently research is ongoing to interview the local stakeholders for their preferred response towards the zero-emission city logistics. And this will help us to further provide valid scenario assumptions and to further improve the usefulness of our results. Well, I would like to thank you for your kind attention. If you want to know more about this particular analysis, it's published in the Transportation Research Record and it's open access. I thank you for this presentation. I hope it inspires you and you will help to enable also the transition to zero emission city logistics. Thank you very much and bye-bye.